Hello and welcome. We tend to think of concrete as, well, just simple gray sludge that hardens into rock. But the truth is, the concrete that's literally holding up our modern world is an incredibly high-tech material, designed with an amazing amount of precision. Today, we're going to dive into the data that forms its secret blueprint.
I mean, really think about it for a second. What allows a massive skyscraper to just pierce the clouds, or lets a bridge carry thousands of cars every single day, year after year, without failing? The answer isn't just about brute force. It's about intelligence. It's all about the engineering.
And that intelligence, it comes from documents that look just like this one. Now, it might look like a boring wall of text, but what you're seeing is the master recipe book for concrete. It tells engineers exactly how to combine ingredients to get a very specific result, and every single step is dictated by data. Okay, let's get into this. Before you even think about mixing a single grain of sand with cement, you have to answer a really fundamental question. What exactly are we trying to build here? The very first set of data points is all about defining the goals for the finished product. First up is what engineers call grade designation, or FCK. Honestly, you can just think of this as its strength reading. This number represents the absolute minimum force the concrete has to be able to withstand without crushing. It is, without a doubt, the most critical performance metric and the #1 data point you have to nail down.
Next, we have something called workability, and this is all about usability. See, a concrete mix can be incredibly strong on paper, but if it's too thick to pump up a building or too watery to hold its shape, well, it's pretty much useless. Workability is the data that defines the concrete's consistency, making sure the crew on site can actually handle it.
And finally, for this section, you have to consider the exposure conditions. Where is this concrete going to live its life? Is it going to be underwater? Will it be exposed to constant freezing and thawing cycles? Is it going to be near a chemical plant? This data is absolutely crucial for long-term durability. So the structure doesn't just start strong, but actually stays strong for decades. So once we know our goals, right, we know the strength, the workability, the durability we need, it's time to write the actual recipe. We need to choose the physical components, and just like in some complex gourmet dish, every single ingredient is chosen based on very specific data. And just look at this. This is only a small piece of the official checklist from the engineering standard. Look at the level of detail here. We're talking cement type, the shape of the aggregate, different admixtures. This is exactly why we need a systematic, data-driven approach. You just can't guess with this stuff. But don't worry, we are not going to go through that entire list. We can actually break it all down into 4 main components that pretty much every concrete recipe needs. This table breaks it down nicely for us. For cement, which is basically the glue of the mix, you need its type and grade. For aggregates, that's your sand and gravel, their size and shape literally form the concrete skeleton. Then there's the water-to-cement ratio, which is so critical. It's what fuels the chemical reaction that gives concrete its strength. And lastly, you've got admixtures. Think of these as special ingredients you add to tweak things, like making the concrete set faster or resist water better. All right, so we've got our perfect recipe. But here's the thing. A perfect recipe designed in a lab is totally useless if it can't handle the chaotic reality of a construction site. And this is where logistical data comes into play. You have to think about the entire journey. Data points like how long it takes to get the mix from the plant to the site are so important because concrete is a live material. It's already reacting and changing in the back of the truck. And how is it going to be placed? Pumping concrete 50 floors up requires a very different consistency, a different workability than just pouring it straight into a foundation. This all leads to another crucial piece of data, the degree of site control. Basically, is the construction site running a tight ship with constant quality checks, or is it a little more relaxed? A site with good control means you can design a really precise, efficient mix. But if the control is only fair, well, you have to account for that unpredictability by building a bigger safety margin right into your recipe from the start. And that whole idea of a safety margin brings us to our final and maybe our most important concept. How do engineers take all of this data, the goals, the ingredients, the site conditions, and use it to guarantee safety against all that real-world uncertainty? Well, they use a formula. Now, I know this might look a little intimidating, but trust me, this single line from the standard is the key to the whole thing. It shows you how to calculate the target strength you need to aim for. Let's break down what it really means. Here it is, the 4-step strategy. Step 1 is your goal, F
That's your minimum passing grade. Step 2 is S, the standard deviation, which is really just a number that represents all that real-world messiness and inconsistency. For step 3, you multiply that inconsistency to create a statistical safety buffer. And finally, in step 4, you add that buffer to your original goal to get your new, higher target. You aim higher to guarantee you never, ever fall short. Which brings us right back to our original question. When you look at those incredible dams, the tunnels, the towering skyscrapers, what is it really that's holding it all together? It's not just cement and stone. It's data. Precise, calculated, and carefully applied data that transforms a bunch of simple ingredients into the very foundation of our civilization. It's the hidden blueprint that makes sure that what we build today will stand strong for all of our tomorrows.